Good morning. Today we are going to discuss some topics in your programming and data structure subject. So recursion. So recursion is a very important concept in programming and data structure. So recursion is nothing but the process in which a function calls itself directly or indirectly is called recursion. That is continuously we can call again and again until the particular target is achieved. So that is the meaning of a recursive function. So where we can apply these recursive, we can able to apply in the towers of Hanai problem, then the tree traversals there, with that is the in order, pre-order, post-order, and also we can apply this concept in the depth first search and etc. So how to implement the recursive? So recursive nothing but so basically a function. Actually, we can able to access or call that particular function until that particular target is achieved. Again and again we have to call. So once the target is achieved or reached, then we can stop the process. So this is a concept of recursive. So how to implement? We can implement this concept through any programming language, C, C++, Java, and etc. So now we'll see the function of recursive. So how to implement the recursive? So here, before that, so suppose if you want to do the factorial of n number. So factorial of n number nothing but the product of all the integers from 1 to whatever number you want to find out. For example, we want to find out the 6 factorial. So here we have a 6 factorial. So here you see 6 factorial. Now how to compute the result? The computation done here, that is a 1 into 2 into 3 into 4 into 5 into 6. So that is a formula 1 to that number, product of all the integers which start from 1 to that particular number. So number nothing but here what 6. So 1 to 6 we can product all the values. So we can get the answer is what 720. So how to, this is the logic, or we can say that this is a steps or algorithm. So how to implement in a programming language. So this is the concept. So the factorial function, if I write the function, here we are passing value n, whatever value you want to pass, maybe 6 or 4, like that. So now for initially we want to check whether if the given the value, given the input n is equal to 0, then we can directly return the result is what 1. Otherwise, we can apply factorial. That is the recursive factorial you have to apply. So n into factorial of n minus 1. So we can call again and again. So what will happen here? So initially we are going to compare 6 is equivalent to 0. No, condition failed. Now come to the second part. In that second part we have a function. That is what n, this is called what recursive function. Okay, this line is called recursive function. So n into factorial of n minus 1. So let us take the example 6. So 6 minus 1, 6 into factorial of 6 minus 1. So now here we have a factorial of 5. So again what will happen? Factorial of 5. So now n is equivalent to what? 5. Okay. So again you have to check whether the n is equivalent to 0. So the process will continue until our target is reached, until the n value is equivalent to 0. If it is 0, then we can return the answer is what 1. So this is what recursive implementation. So this is one question I have taken from the GATE 2018 paper. So this is also the example of recursive. So recursive nothing but what the function call and again until the particular target is reached. So here you see, so here, so the main part of this program is what function calling. This one is what function calling. Okay, this is what function calling. Okay, so this is the main program. So now what we are going to do, cal c 4,81. So what is the meaning of that? Cal c nothing but function name. So here also we have a function name. Okay, so the function name So here also we have a function. So here also we have a function definition. So what we are going to do, we are going to compare. A minute. So cal C 4 comma 81. This is what function calling. So in that function calling we have a 4 comma 81. So what will happen, the compiler going to compare the same function which is available in that program or not. So that is what the function definition. Yes, so here it is available. So it will go back and also compare the parameters. So here we are passing 4 comma 81. So what is the meaning of that now? A is equivalent to 4, then B value is equivalent to what? 81. So initialize the C value, C empty, then counter value. So C is the integer variable, counter value incrementer. If B is equivalent to 3, so return A, that is the A value multiplied into 3 times. Otherwise, so what to do here, we have to perform some mathematical computation. So what is that? C is equivalent to cal C of A comma B comma 3. So what we are going to do, the B value, what is the B value? 81. 81 is divided by 3. Okay, that value stored in here. So the process will continue again and again, again and again. So till when B value is equal to 3, then we can return the result. So what is the aim of this program? We want to return the result of A, and also the final conclusion is what we want to get the counter value. Counter nothing but what the step value, the counter plus plus no. So how many times the steps will be continued here? Okay, the counter value, and also we want to return the A. So this is the that how it is executing internally. So initially we have the function is what in function calling we have a cal C of 4 comma 81. So you just assign the A value is equivalent to 4, B value is equivalent to 81. Okay. So after performing that B value divided by 3, B is equivalent to 81. Now the counter value is equivalent to 1. Again, if it is not equivalent to 3, okay. So what we are going to do, again do the A, that is the 81 divided by 81, initially 81 divided by 3. Okay, so now the answer is what? 27. So now the A value is equivalent to 4, B value is equivalent to 27, counter value is incremented by 1, so the counter value now 2. Then again the same procedure, B values is not equivalent to 3, so again we can do the 27 divided by 3, so 9. Now B value is equivalent to 9, counter value is equivalent to 3. So one more step we have to perform. Why we want to perform one more step? It is not equivalent to 3. Our aim is what? We want to check B value is equivalent to 3 or not. So it is not equivalent to 3. So you have to perform one more step. So 9 divided by 3 is equivalent to 3. So A value is as it is, no change. A value is equivalent to 4, B value is equivalent to 3, counter value increment. And now we have to check the condition whether the B value is equivalent to 3. Yes. When counter value is equivalent to 4, now we got the answer B value is equivalent to 3. So now you just to stop the process. So the counter value is equivalent to 4. Now the B value is equivalent to 3. So the condition satisfied. So what we are going to do, we want to print the A value. Okay, how many times we want to print the A value? The A value we have to print in the 3 times. A into A into A. So 3 times we have to multiply A value. Answer is what? 64. A value. In that A variable, we got the result is equivalent to 64. The counter value is equivalent to 4. Okay, so this is the solution of this program. So the output of this program, 4 nothing but what? The counter value. Counter value we have received is equivalent to 4. Next, very important, arrays. So array is nothing but what? It is a basically it is a data structure concept. It is a linear data structure. So linear nothing but what? The elements, all the elements, it is formed like a sequential manner. Okay, so this is a linear data structure. What is the meaning of array? Actually, it is a collection of items stored at the contiguous memory locations. The idea is to store the multiple items of same type together. Okay, so this makes it is easier to calculate the position of each element. So why it is very easier? So all the elements are stored in the form of sequential manner. So we can easily find out the that is the position where that particular element is available in which position. So we can able to find out. That is the best, easiest method of using the array concept. So here you see. So this is the memory location. So the 0, 1, 2, 3. These are all the index. So you know that arrays always start at the 0th location. Okay, this is what memory location. So here we have a data, that is a U, B, F, D, A, E, C. These are all the data. So this is the variable declaration. So here we have a ARR. ARR. Why we want to? That is the variable declaration. Suppose you have some n number of elements of the same data type we want to form. Okay, suppose we have a student mark list. So student mark list, nothing but what? So we have a n number of students. Okay, n number of students are there. So now we want to assign the same variable name. Okay, so in that case, what we are going to do, we can use the variable name ARR. Then we have a location. Maybe you want to store some 5 students details or 10 students details. Then we have to mention that the number of location. So here array of 0. So if it is like here array is a variable name, 0 nothing but index of the element to be accessed. So 0th element, if you want to access the 0th element, so it is pointed to here. Suppose we want to refer the first, that is the first element we want to refer, then it is referred to the first position. So likewise, we can able to access the elements with the help of index. So the advantages of using array. So it is a random access of elements. So how it is possible, no, using array index. So array index always started at the 0th location. So we can find out the elements. Use of less line of code as it creates a single array of multiple elements. So this is a very, very useful one because that is we have some collection of elements are available. All the elements are written the same data type. So that case, what to do? We can use a single variable name. We can use a single variable name that is enough to store the n number of elements using that array concept. Easy access to all the elements. Traversal through the array becomes easy because we can, if we are going to use a for loop or while loop, so it is very easiest one to access the elements. And also sorting is also very, very easy. Disadvantages, it allows a fixed number of elements to be entered, which is decided at the time of declaration. Unlike the linked list and array, C is not the dynamic one. So this is a major drawbacks when you are using that array concept. So in order to avoid that, what we are going to do, suppose we want to allocate the elements dynamically, you want to allocate. So what we are going to do, we can go for the linked list, then we can achieve that. Then insertion and deletion of elements can be costly since the elements are needed to be managed in accordance with the new memory locations. So suppose if you want to insert or deleting the elements in the case of linked list node, so it is very easiest. So wherever you want to insert or deletion, that is possible. But here this is a sequential manner, so we have to follow some rules. So it is not like that linked list. So this is a major drawback of using array. Suppose we have this is what character array. So character array, if you want to declare, so we can use the curly brackets. Then the characters are separated by the comma. So each and every characters are mentioned in the form of single quotes. So this is what integer allocation. Suppose if you want to refer the array 1 of 0, okay, it gives us the result is what G. So array of 1 nothing but what this one. This is the array of 1. So here we want to refer array of 1, the 0th. So this is what 0th location. Okay. So this is the 0th location of array 1. So here we have a G. So it returns a result G. Next is an array of 2 of 3. So array of 2 of 3 nothing but what? 0th location. 0th location of array of 2. First location of array of 2. Then second location of array of 2. Then the third location of array of 2. So it gives the result is what? 40. So the result is here 40. So next we want to perform some perfect sum problem on the array concept. So what is the meaning of here? They will give one array. Then in that array they have given some inputs, and also along with they have mentioned some target. That is that the task is to print the subset of elements. For example, here array declaration we have integers 5, 10, 12, 13, 15, 18. So here they have mentioned the subset value is k, where k value is equal to 30. So what we are going to do, you just make it as an array in the form of subset. So what are the elements? If you are going to add any 2 elements or 3 elements or a number of elements, that the target is what? The task is what we want to print the 30. So here they given the elements. So our task is what? 30. So what are the elements supposed to be added? Will give the result is what? 30. So what we are going to do here? 12, 18. It will give the result is what? 30. Okay. Likewise 5, 12, 13. It will give the result 30. Likewise 5, 10, 15 also. It gives the result is what? 30. Okay. So this is what subset. We are applying the subset concept on the array. So here you see next one array given, that is a array declaration 1, 2, 3, 4. Then the task is given 5. Okay, so what we are going to do? Which are the 2 items when you are going to add? Will give the result is what? 5. Yes, 2, 3. When you are adding 2, 3, that gives the result as 5. So likewise, when you are going to add 1, 4, which gives the result 5. So the next one, this question I have taken from 2019 Gate question. So here given array in array declaration, they have mentioned some n number of elements and pointer variable. IP is here pointer variable which assign array plus 4, ARR plus 4. AR is nothing but what? It's array declaration. Here see, this is the array variable which holding these are all the elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, then 1, 2, 5. So now what we want to print? IP of 1. That is that IP. IP is nothing but what? Array pointer. Array pointer of array of 1 we want to print. So how to do it? So we'll see what is the result. So here so this is the array of elements. So from 0th location to 12th location. So these are all the elements are available. So now the IP is pointed to 0th location. Okay. Initially the IP is pointed to a 0th location. Now it is incremented. That is a ARR plus 4. It is assigned to the ARR plus 4. So what will happen? ARR plus 4. So it is now it is pointed to. So initially it is pointed, IP is pointed to here. So the next level what will happen? The IP is equivalent to what? ARR plus 4. Okay, so now ARR plus 4, it gives the result is what? 5. Okay, so now initially it is pointed to 0th location. Now it is pointed to 4th location. So here. Okay, so now starting first 4 position. So now IP is pointed to what? ARR plus 5. So So now the printf system call one more position is to skip, so it will become pointed ARR plus 5. So actually what will happen here, initially IP is here, now that should be incremented plus 4. So what will happen, ARR plus 4, that is incremented by plus 4. So now it is pointed to 5th. So the printf will print the value at the 6th position. So the value is what? 6 will be printed. So the option A is correct. So the next one is what the expression infix, prefix and postfix expression. So generally we know that the infix nothing but what, first operand, operator, then operand. So prefix expression nothing but what, first operator, operand, then followed by operands. Then postfix nothing but what, first operands, at last we have operators. So how to do that, the infix to prefix? So we know that initially, so what to do? First, the given the infix expressions should be, we have to perform that reverse operation. That is, whatever expressions are given. For example, here a plus b plus c asterisk of c. So what we are going to just to do the reverse. You just, that is a law. We can start from the end of the character. We can do that. So just reverse the statement. So what we are going to do? So c asterisk b plus a. Okay. Then after that we can apply the postfix expression. Then whatever result we obtained on the step number 1. So that becomes what, the result of the postfix. Next, the result of the postfix expression, again you have to apply the reverse operation on that, then we can get the prefix expression. So this is how to convert the infix to postfix. So infix to postfix, to convert the infix expression to postfix expression, we will use the stack data structure. Okay, by scanning the infix expression from left to right. When we get any operand, simply add them to the postfix form. And for the operator and parentheses, add them in a stack, maintaining the precedence of them. So actually what we are going to do, first we can read the characters from the infix expression. If the character is the alphanumeric character, then add character to the postfix expression. Else, if a character is opening a parenthesis, then push that opening parenthesis into the stack. Else, what we are going to do, if the character is equivalent to exponential, then push that part into the stack. Otherwise, if character is a closing parenthesis, then again apply, whether you have to check whether the stack is not empty, then stack top is equal to hash, that is the opening parenthesis, then do pop and add item whichever available from stack to the postfix expression. Then we can pop all the items from the stack. Otherwise, while stack is not empty, add precedence of character less than or equivalent to precedence of the stack top element. So the same thing how to continue until that all the contain some, that is the characters, all the characters are available. Then while the stack contains some remaining characters, then do pop and add to the postfix expression. Then we can get the result. The same, then the final output we can get it on the stack. So the result in the form of a postfix expression. Suppose the given the expression likewise, the infix to, they are asking convert infix to postfix. They given the expression likewise. So here you see, so generally we know that the infix nothing but what? We have a operand, operator, then we have a operand. So here you see the first, we can take first parenthesis, that is the first part, a plus b, then exponential d. So here you see we have a two operators are there. One is the plus, then another one is what? Exponential. So here one more thing here we have to concentrate that that is the exponential, that is that precedence also, higher precedence get the highest priority. So now what to do? You just evaluate here. So a plus, then bd, then exponential. Then again we are applying, then we can get the answer a, then b, d, exponential plus. Now let's move to the second one, which is the e minus f. So the result will be what? So we want to convert in the form of postfix expression. So here we can get the result ef minus, till now we have a, can get the result likewise. Then again you can apply. Now among the both operators which has to be evaluated, slash as highest precedence, so we will evaluate it first. So the final result we can get it, the postfix expression will be a, b. So a, b, d, these are all the operands, then exponential, then plus operator, then ef minus slash g plus. So the output will be likewise a, b, exponential plus ef minus slash g f. So the next one is very interesting one, that is the evaluation of postfix expression using star. So this is the algorithm. So we have a postfix expression. Now we can read the postfix expression from left to right until closed parenthesis encounter. If here we have to consider two things, operand and operator. If operand is encountered, then push it onto the star. If operator is we can find operator, then what to do? Whatever elements, topmost two elements are available, you just apply whatever operator, we can get it now. Okay, so that we can apply on the top two elements, then we can get the result. So evaluate B operator A with the help of whatever operators are available or given that expression. Now we can push the operator A onto the stack. Get the result is equivalent to pop, then we can end. Now we'll see sample. So here we have, this is for the postfix expression equation. So now we can start. So we can read the statement. So here we have 4 is what? Operand. Then we can push onto the stack. Next one is what? 5. So this is also operand. They can push onto the stack. So 4, then 5. Then again we have a 6. 6 also operand. Then we can push to the stack. Now here you see operator. What is the operator here? Asterisk. So what we are going to do, you just apply the that is a multiplication operator on the topmost two elements, 6 and 5. So we can perform the multiplication on the 6 and 5. Then we can get the result. We can get the result is what? 30. Again, we can push it on the stack, topmost stack. Now we have a plus. So now we have a plus. So what to do? You just apply this addition operation on the 30 with 4. Now we can get the result is what? 34. Now we can pop it out. We can pop it out from the stack. So the result is what? 34. So this is a table that is how we can. What are all the steps we have followed? So from that, so what result we got it? So these are the steps. So step number 1, we can read the input. That is a 4 is the operand. So we can do the operation, push operation, where we are going to push on the stack. That is a 4. So here there is a no calculation. So why we don't have any calculation? So this is the value we got it. 4 only we got it. We don't have any operator. The next input is what? 5. So you have to perform push operation. So now on the stack we have a 4 and 5. Then 6 also operand. We can perform the push operation in that stack now 4, 5, 6. So next is what? Next input is what? Multiplication. So this is what? Operator. So we have to perform the operation. So the topmost two values. So 5 and 6. We can perform that multiplication on that 5 and 6. We can get the result is what? 30. After performing the calculation, again you just push it on the stack. Then next one is what? Plus operator. Here also we are going to perform the calculation. So in the topmost stack we have a 4, 30. Now we can perform the operation. We can get the result is what? 34. So the final result is what? 34. Then we can return the result from the stack. We can perform the pop operation. You just pop it out. So now the stack is empty. The result is what? 34, which is available in outside. One more expression, postfix expression. So we have a 4, 5, 6 plus asterisk. These are all the inputs given. So now what we are going to do? So the result of evaluating the postfix. So here you see 2, 4, 6. So here we have a plus operator. You just apply the plus operator on the 4 and 6. So the result is what? 10. Okay. So now in that stack we have a 2, and then 10. Okay. Now the plus operator work is over. Next we have a asterisk. So asterisk nothing but what? You just multiply these two. So now we can get the result is what? 20. Okay. So again we have a we can read the characters here. We have a 2 is the input, an iron and a 3. So here you see slash. So you can apply that slash operator on the 9 and 3. So we can get the result is what? 3. Okay. So in the stack we have a 22, 3. So here you see plus operator. So you just add the 3 plus 2. Okay. So 3 plus 2. Okay, get the result is what? 5. So now we have a 20 in that stack 20. So now currently we performed that 3 plus 2. So the result is what? 5. We want to perform that multiplication. So 20 into 5 is equivalent to what? 30. So the result is 30. So the final output 20 into 5 is equivalent to what? 100. So these also a sample question I have taken from Gate CSE question back. So here given the postfix form of x asterisk y plus q slash v is equivalent to how much they are asking. So here they are asking the postfix expression. So actually how to do it here? Here you see x asterisk y. So the first step is what? Xy asterisk. Okay. Then we have to concentrate on the u divided by v. Okay. So the result is what? uv slash. So first we can get the result x into y. Okay. xy asterisk, then the second part uv slash. Okay, then we have to perform one more operation. So in between we have a plus, here we have a plus, so the result is what? Xy asterisk then uv slash, at last we have a. So in general, postfix expression, if they are asking postfix, convert the postfix expression. So what we are going to do, so that we have a first operand, then followed by operator. Okay, operands, then followed by operators. That is a general procedure. Then one more example, result evaluating the postfix expression 10 into 5 plus 60 into 6 slash 8. So here also the same procedure. Here you see 10, 5 plus. So 10 is the operand, 5 is the operand. Now we want to apply plus. So what will happen here? We can get the result is what? 50. We can get the result is what? 50. Now in the stack we have a 50. Next we'll see 60 and then 6. So apply slash operator here. So the result is what? 10. So now in that stack we have a 50. Then the topmost 50 we have a 10. Okay. So then followed by asterisk. So what to do? We want to multiply these two. Okay. So 10 into 5. Okay, sorry, actually 10 in 10, 5. Actually here we have a plus operator now. So what to do? So here we have a 10, 5 plus. So 10, 5 plus. So what will happen? 15. Okay, 1, 5. 10 plus 5 can get the answer 15. Next here you see 66 slash. We want to apply. So we have to apply the slash operator on the 60 and 6. So what is the result? 10. Okay, so the two operations are over. Now then followed by asterisk symbol. So what to do? Whatever values are available on the stack, we have to apply the asterisk. So here you have to apply the asterisk. So these two values are available on the stack. Okay, these two values. So now we can apply the asterisk operator. We can get the result is what? 150. Okay, so the we can that input string we have minus. Okay, minus, and also here we have a 8. 8 is left to know, so 8 then followed by minus. So now we can apply the minus operator on the 150 and 8. So which is available on the stack. So 150 minus 8. So the result is what? 142. So this is the way when they are giving the expression in the form of postfix. So you have to evaluate. So we have to apply the that is the normal stack rule. We have to apply. Then we can get the result in the form of postfix expression. So this is the way you have to evaluate the postfix expression. Thank you all.